So let's take a look at this problem. If rod CD is rotating with angular velocity of 4 radians per second, determine the angular velocity of rods AB and CB at the instant shown. Now, one thing to notice on these, again, this is under the instant center of zero velocity section, but we still have to use stuff we've learned from the other sections. In particular, remember, if something is rotating about a fixed point, the velocity at the end of the rod connected to that point will be perpendicular to the rod. So again, in this case, we have at A and at D, we have a fixed axis about which the rods are rotating. So keep that in mind. So we look at a picture like this, we see that, again, everything, this one is rotating about A, this one's rotating about D. Now, we don't know much information about AB. We do know that it's 1 meter long. Now, we do know that CD is rotating at 4 radians per second. And we also know that its length is 0.5 meters. So we can maybe use this to do some calculations. Once again, as I said, because this is a fixed point and this rod is rotating about this, then this velocity is going to have to be perpendicular. And of course, the velocity is always omega r, which is going to be 4 times 0.5, which is 2 meters per second. And we don't know hardly anything about CBC except that it's 0.4 meters long. And again, we don't know much about AB. Once again, though, we know that this bar is rotating about A. Therefore, the velocity at B has to be perpendicular. So VB is going to look like that. And we can put some angles on since this is 30 degrees, we know that if this is a right triangle, this has to be 60. Therefore, this has to be 30. So we have something like this. And then again, since this is perpendicular, that's 90 degrees. So this is 30 minus 90, which is 60, like this. And so let's see what we can calculate. Over here, we actually have the velocity. And now, again, since this is perpendicular, then at this instant, the velocity is going to be going in the negative x direction. So over here, we can say that the vector VC is going to be negative 2I. Now, over here, we don't actually know what the velocity of B is, but we can break it down into components. So again, the velocity of B is going to be, again, so if B is directed this way, then the x component is going to be VB cosine 60 I. And you can see it's directed in the negative x direction. So we can put a negative in front. Then over here, this is going to be VB. If this was cosine, this has to be sine. And once again, it's going in the negative y direction, like this. And again, just as before, whatever this angular velocity is, VB is going to have to be omega r. And we could maybe call this omega AB. Cos 60. And this will be omega AB or sine 60. And of course, we don't know what omega is, but we do know that r is 1 meter. And cosine of 60 is 0.5. And this is 1 meter. And sine of 60 is 0.866 J. And we can rearrange that a little bit so that we finally get VB is equal to negative 0.5 omega AB. And there should have been an I in here. I left the I off. This. And so we have this information here. We have this information here. So we want to put these together with this link BC. Now notice again, B, we have its direction for the velocity. C, we have its direction. So let's take a look at BC. And this is where we're going to end up using the instant center. So let's take BC. And velocity of B. This is 60 degrees. And now we know that, let me put this in pen. We know that the velocity of C is going to look like this. And we know the velocity of B is going to look like that. And we have the velocity of B here, velocity of C here. Let me move these up a little bit. So velocity of C was negative 2I. And we also know if we draw perpendiculars from this velocity and from this velocity like this, the instant center is going to be wherever these two meet. And now over here, since this was 60 And this is 90 degrees. This has to be 30 degrees. And so once again, looking at our little triangle here, if this is 90 degrees and that's 30, this has to be 60. Like this. And now the only length we know is this one. This is BC was 0.4 meters. Now we can use all of this to try to figure out what all these sides are. Let me call this side here H. And now this side here, we can calculate this. We should maybe find H first. Remember that H cosine 30 degrees is going to be equal to 0.4. You know, usually we know the hypotenuse, but we don't know one of the sides. This time we know one of the sides, but not the hypotenuse. So we have to use this, that H cos 30 is going to be the adjacent here. So that'll give us H is equal to 0.4. Yeah, let's see. 0.4 divided by cos 30 is going to be 0.462 meters. So that's H. Now that we have H, then we can find this side. So we can use either 30 or 60. Let me use the 60, and then it'll be an adjacent. So this side is going to be 0.462 cos 60 degrees, which comes out to be 0.231 meters. Now we have all of our sides. And remember, again, this is the incident center. And so we can start calculating some things. We know the velocity of C here, and we know the radius. So the velocity of C has to be omega. I'll just leave the omega BC times the radius. And in this case, we know that this is 2. I'll just make it 2. We'll keep track of the direction. So this is 2 omega BC. We know this radius is 231. Remember, now that we're working on BC, it didn't matter what the original radius out to C was. Remember, before, the radius from C to D was 0.5. Now, that doesn't come into play at all now, that radius there, because we're working specifically with the part BC. And then omega BC is equal to 0.866 radians per second. Now that we know that, we can go back here and we can figure out what the velocity of B is, because we know this radius here. So we can say velocity of B, let me put this over here, velocity of B is equal to omega BC times its radius. Now, its radius is going to be H. And so the velocity of B is going to be equal to 0.866. I don't know if that's clear. 866. I better rewrite that. Times this H. And that ends up being 4 meters per second. And then finally, If you want to find, well, I guess that's almost all we need. We do have to finally find one more velocity. Now we have to go back to this link here. We need the velocity, or excuse me, the angular velocity of AB. And so go back to that. And we know that this, we found out this was velocity of B was 4 meters per second. And we know that this was 1 meter. So now again, we're looking at this link now. And so we know this velocity, but we don't know the angular velocity of AB. Okay, actually, I got interrupted there for a second. So velocity of B is omega AB R, and the velocity of B is going to be actually that's a mess there. It's going to be 4. We know velocity of B, and omega AB we don't know. And we know this is 1 meter. And omega AB is 4 radians per second, like that. So again, once we found the velocity of B from link BC, we could use that on link AB to find the angular velocity of AB, like that. Now, I guess one thing I did previously, I guess we didn't even need, it turns out we did not actually need all this stuff here for the velocity of AB. You could use this if you wanted to know the actual vector form of the velocity of B. So if you wanted to use that, now that we have omega AB, we can use that again. This was not needed for the problem, but we can put this in. Let me just note here, not needed. Was this that the velocity of B was equal to the negative 0.5 omega AB I minus 866 omega AB J, just using what we found previously. Then if you put these in your calculator, you get negative 2I minus 3.464J. Again, the problem didn't ask for this part here, but since I had already calculated this VB here, we can do this here. You could have done that, or if it had asked for VB, the vector form, we could have just gone up here since we found VB up here, and we could have done the same thing. We could have said this was at 60 degrees. We found VB to be 4 meters per second. We could have just used the cosine 60 in the negative direction to find the I component, and we could have used sine of 60 times 4 to find the J component. So you could have done that either way.